Okay, so today we're going to talk about finding all of our rational zeros for a polynomial function. Before we get into how we're going to go about doing that, I want to make sure that we make a connection here between zeros and factors, right? So from one of your previous homework problems, you had to solve this polynomial equation by factoring, right? And so, of course, you did this by grouping. So you group the first two, you factor out a GCF and get x plus 6. Then the next two, factor out a negative 4, and you can get x plus 6, which is great because factor by grouping only works as long as your parentheses are the same. So now your factors are x squared minus 4 and x plus 6. Then let's see, you could go ahead and factor down x squared minus 4 into x plus 2 and x minus 2. And then that, along with x plus 6, are all the factors for that polynomial equation. And at this point, we're going to set our factors equal to 0 to find the solutions. Right? And quickly, you did all this in your homework, you're going to get x equals negative 2, x equals positive 2, and x equals negative 6. But can we make that connection between finding the solutions this way and our synthetic division? Right? What if I told you that x plus 2 was a factor for this polynomial up here? From the homework a couple of nights ago, you know that you could do synthetic division. Right? With synthetic division, when we set this up, right, we're going to put negative 2 in the tiny box. Negative 2 coming from this factor here, x plus 2. And so when we put negative 2 in the tiny box, we're going to put the coefficients of the degree 3 there next to it. So 1, 6, negative 4, and negative 24. And I'm going to do this pretty quickly. You can always stop the video if you feel like you need some time to digest what we're doing. But we've already done a homework assignment on synthetic division, so hopefully this is pretty easy stuff for you at this time. But take a look. Since x plus 2 is a factor, then we should get a remainder of 0. But a factor of x plus 2 correlates to a 0 or a solution of x equals negative 2. And so since it's called a 0, we should get a remainder of 0. So there's a lot of ties between our factors, our solutions, and synthetic division. Okay? Of course, at this point with our synthetic division, we would get a new polynomial by dropping the degree, and we get x squared plus 4x minus 12, and we would factor this guy down, and we would have to factor it into x plus 6 and x minus 2. And what you would see here is that you have the other two factors that you had over here. So I guess what I'm trying to say is, if you know that a solution to this polynomial function, or a 0 or a root, is negative 2, that's going to automatically correlate to a factor of x plus 2. So if we knew that all of our solutions were negative 2, 2, and negative 6, that would give us factors of x plus 2, x minus 2, and x plus 6. And if I wanted to get back to the original polynomial, I could just FOIL all that out, distribute all that out, and get back to the original polynomial. I'm going to make that connection a couple more times throughout the notes, but I wanted to kind of get that base down before we get into the rest of the notes. Okay? All right. So the actual point of the notes today is to find all the roots of a polynomial function, and we're going to use the graphing calculator to help us do that. So if you need to pause the video and go grab your graphing calculator, do that really quick, and then come back so you can follow along with the button pushing as I do it in the notes. Okay? All right, so let's get into it. We know that the solutions to a polynomial function are also called the x-intercepts. They're also called zeros, and they're also called roots. Since they're called x-intercepts, that means that as long as they are real roots, real zeros, real solutions, then if we graph the polynomial function, all those solutions should be where the polynomial crosses the x-axis. So when we graph whatever polynomial this guy was, it hit the x-axis in 4 spots. 1, 2, 3, 4. That means there were 4 real solutions. Okay? There may be imaginary ones as well. We're not going to be able to see them because when we have imaginary solutions, those are, yes, solutions, but it will not tell you where the graph hits the x-axis because it's not real, it's imaginary. Typically speaking, the degree of the polynomial will tell you, well, not typically speaking, all the time it will tell you how many solutions there are. Most of the time it will tell you how many places you should expect that function to hit the x-axis. Now that's not always true because like we just said, sometimes there are imaginary solutions and so therefore it would take away the number of times the function would hit the x-axis. So just some things to keep in mind as we go through this. So, ways to solve a polynomial equation. So far we have talked about factoring. That was all about your last homework. And 2 homeworks ago, it was all about long and synthetic division. We could add long division into here, but we're not going to want to do long division when we can just do synthetic division. So, and a quick nod to if your polynomial is a quadratic, then you can always use the quadratic formula to help you find solutions. But there's one more way to do it too, and that's through graphing. And that's what we're going to do today. Okay? Before we get into graphing, if you happened to not have your graphing calculator, there are ways to find or create a list of possible zeros by using something called the rational zero theorem. To get possible zeros for any polynomial, what you could do is factor down the constant term. So list all of the factors of the constant term, and then list all of the factors of the leading coefficient. That's the first coefficient. And then use those factors and create fractions, basically. And those fractions will give you possible zeros. Okay? So here's what I mean. If we're given this function right here, so 2x to the third minus 4x squared minus 10x plus 12. Then what we're going to do is we're going to factor down positive 12. Well, positive 12 will factor into 1. The factors of positive 12 are 1, 2, 3, 4, 6, and 12. And because we understand that 2 negatives can multiply to a positive, then we probably ought to list those as plus and minuses, right? And then we need factors of the 2. The factors of 2 are 1 and 2. And again, because we understand that 2 negatives can multiply to a positive, we got to make these plus or minus as well. Now, to come up with your possible zeros, we want to take these guys and put them over all of these guys, and that'll create our list of possible zeros. Okay? Now, I got more room on the next screen, so I'm going to move over. So this is something that you don't need to write down anymore. Okay? Just kind of watch how this works. So again, we've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12 as factors of 12. Then we got plus or minus 1, plus or minus 2 as factors of 2. To create our possible zeros, we're going to take our p's over our q's, or in other words, make fractions. So I would want to take positive 1 and put it over positive 1. And 1 over 1 is going to be 1. And do that for every possible combination. So take the 2 from the 12 and put it over the 1 from the 2. So we get 2. 3 over 1 is 3. 4 and 6 and 12 over 1 are all 4, 6, and 12. And remember that these are all plus or minus for reasons that we talked about before. Then we got to go back through with those same factors of 12 and put them all over 2. So we'd have 1 over 2. Then we'd have 2 over 2, which is just 1, and we already have a 1 right there, so we don't have to worry about doing that. 3 over 2 would be a possible, and these are all plus or minus as well. And then 4 over 2 is 2, we already have 2. 6 over 2 is 3, we already have 3, and 12 over 2 is 6, we already have 6. So these are all of your possible solutions, all of your possible zeros. There's 16 of them there. Okay? What you would have to do at this point is just start picking some and put those possible solutions or zeros into synthetic division and see if it works. For example, I don't know, 2. We'll try 2 first. So 2 is going to go in the box to synthetic division. Our coefficients come over 2, 2, -4, and -10, and 12. So 2 falls. We multiply up and get 4. So this is 0. Multiply up, we get 0. This is -10. Multiply up, we get -20. And you add this and you get -8. Since this remainder is not 0, that means that 2 is not a 0 or a root or a solution, right? So what we have to do at this point is go back to the drawing board and pick a different possible solution. So we can try, since I tried 2, it didn't work, I'll try -2. Again, I'm just picking numbers. I have no idea if they're going to work or not, but lo and behold, this one does. Okay, because the remainder is 0. That means that -2 is a solution. It also means that x plus 2 is a factor for that guy right there. Remember that we always change the sign when we have a factor in order to put the number in the tiny box? So just as a quick reminder, x plus 2 would be a factor because -2 is a solution. Now that we have this factor down, we're going to drop a degree. So these are going to be our coefficients on a quadratic. And at this point, we could factor this guy down. And we can factor it down into, well, first of all, we'll get that in a second. So 2x and x. We need factors of 6 that when you multiply one of them by 2 will add to -8. You should know all of this. And so let's make this -3 and +2, and that would get it done. No, sorry, -2. And that would get it done. Okay? Then at this point, we would set these guys equal to 0 and find the rest of the solutions, which are going to be 3. And add 2, divide by 2, you get 1. These 2 possible solutions were wrapped up in here as well. So we did have them listed, we just didn't try them. Okay? So that's one way you could do it. But as you can see, this is terribly inefficient. It could take forever. I could end up having to basically just randomly pick 9 different numbers to try in that box before one actually worked. So there is a better way to do it. We asked you guys to get graphing calculators for a reason, and that's what we want you guys to actually use. So while this is a possibility, in case you don't have a calculator, we want to talk about how to use the calculator. And I'm going to introduce a function here that we haven't done yet, that you may get a little bit mad at me over, but that's okay. Now that if we see it now, it's going to make our life a little bit easier. So with your calculator, if you're going to find the zeros, what we're going to do is obviously type in the function into your calculator and graph it. Like we said before. So x to the third minus 2x squared minus 5x plus 6 is when it's graphed, it looks like this. Solutions and roots and zeros and x-intercepts are all the same. So when we graph this guy, it looks like the graph crosses the x-axis at those 3 points right there. What you could do, you TI people at this point, is go to second, calculate, and 0. Set your left bound and your right bound. Remember your walls. Hit enter, and it should give you that 0 right there. Okay? You can do the same thing here and the same thing here to get those zeros. Okay? And I wanted you to know that function was there. But there's also a table that will pop up. We can get into a table and go looking for our solutions this way. If we're looking for x-intercepts, then we're looking for points where the y-coordinate is 0. So in your table, it will give you it will give you a lot of points that are going to be on that graph. And so we go through and look for the points where the y-coordinate is 0. And that will give us our solutions, our roots, our zeros, or our x-intercepts for our graph. Okay? I'll show you in just a second with our examples how to get to all of that. Now here's the only thing. This is too easy to find all your zeros. So what we're going to tell you, not to mention it won't get you to all your solutions, because like I said, if you have imaginary solutions, you're not going to see it in the graph. So we do have to make sure that we're looking for all of the zeros. So there's one condition that we put on using your calculator, and it's that you can only use your calculator to find 1 0. then you have to go into synthetic division and go into your factoring methods to find the rest. Okay, just find one, which means I should be seeing a lot of synthetic division and factoring going on after you've used your calculator to find a zero. You can't just write down 3 answers and go on. You'll get no points for that. Okay, so just so you understand that. All right, so let's go do some and get used to looking up the solutions, the zeros, and go from there. Okay, so first function looks like this: a cubed minus 10a squared plus 34a minus 40. Okay, so let's get into your graphing calculator and type this function in. Okay, so you go to y equals, and I know that the variable that we're using there is a, but we're going to use x instead in our calculator. So x to the third. To get x to the third, hit your x button, then your caret button, your hat button, or whatever you want to call it. This guy right here, and then hit a 3. It may not look like what mine looks like. It's a little bit different version of your calculator, so it might look a little bit different in your screen. But we're going to type that in. Then minus 10x squared, then plus 34x minus 40. Hit enter, hit graph. There's your graph. Now, if you can't see the graph, you might need to go into Zoom and just hit Standard. That'll set all of your windows to negative 10 on the x-axis to 10 on the x-axis, and then negative 10 on the y to 10 on the y. And then you'll be able to see the graph a little bit better. Okay? So as we see, the graph only crosses the x-axis in one place. Now, this is a degree 3 polynomial, so there should be 3 solutions, which means that we're going to have a couple imaginary solutions, right? But at this point, yes, you could go into second, calculate, go find a 0, and then set your left bound, right bound, right? Your walls, right? So arrow up to set your left wall, then arrow over to set your right wall on the other side of that possible 0, and then hit enter again, and there will tell you that your 0 is 4. Okay, that's one way to do this. Or the table function you will find right above your graph button. So if you hit second, and then the graph button, which will send you to a table, here's your table. That's where that snapshot came from. And if you go down through the y column, here's a y value of 0. This is where your x-intercept would be, at 4. So that's going to be a solution. Okay? That means we can go back to our problem. We know that 4 is going to be a solution. So we're going to put 4 in a tiny box. Which means, by the way, that x minus 4 is a factor of this polynomial. Okay? Now, we're going to do synthetic division, so we bring our coefficients over. Drop the 1 to get us started. We multiply up. Add those to get negative 6. You multiply up. Add those. There should be a positive 10. Multiply up. You get 40. The remainder is 0, and it should be because 4 is a 0. Now we've got to drop a degree and write down our new polynomial, x squared minus 6x plus 10, at which point we're going to try to factor and set our factors equal to 0. The problem is this guy won't factor. So we have to use quadratic formula. So opposite b gives us positive 6 plus or minus the square root of b squared is 36 minus 4ac gives us negative 40 all over 2 times a gives us 2. So positive 6 plus or minus the square root of negative 4 all over 2. Negative 4, the square root of negative 4 is going to give us 2i. Then we divide out common factor from those 3 and we get 3 plus or minus I. So to list to find all the zeros, that would be x equals 4, 3 plus I, and 3 minus I. Okay? And that's it. And then when we're done, I say that's it, but that's a bit of a process. But we're done with we have our zeros. And so as you see, 2 of our solutions are imaginary, and that explains why the graph only hits the x-axis in one spot. Okay? All right, let's walk through another one before we turn you loose onto how to do this all on your own. Okay? So, find all the zeros of this polynomial equation means we're going to bring up our graphing calculator. And I just realized you did not see any of that last example, so you can see this one now. Sorry about that. Let's go through this one, and this should help a lot, right? So here's our equation. Type in our equation. So we need x. Oh, wait, clear this out. We hit x, hat button to the third. Minus 6x squared. Then we've got plus 6x, and then plus 8. Hit enter. Graph this guy, and there it is. And so this graph hits the x-axis in 1, 2, 3 spots. And so we know we're going to be looking for 3 real solutions. So to do that, we could do our second calculate, but the table is easier. So hit the second button and the graph button, because that's where the table is located, right above there, and you get this. Okay? You're looking down your y column, and you're looking for where y is 0, and there's one right there, right? So that means one of your solutions is going to be a 4. If you go back to the graph, that makes sense because 4 is right here, and it does look like it goes right through 4, the graph does, on the x-axis. So, all right, so we know that 4 is one of our solutions. So we use 4 in our synthetic division. 4 in tiny box, 1, -6, 6, and 8. Drop down the 1, multiply up again, multiply up again, and we get a remainder of 0. That's what we want. So 4 is a solution. Oh, by the way, x minus 4 is a factor. Now, we want to drop a degree and rewrite our new polynomial, which is a quadratic, and then try to factor this guy. Okay? But unfortunately, it will not factor again, so we have to go to quadratic formula. Opposite 2 plus or minus the square root of b squared would give us 4, minus 4ac would give us plus 8, all over 2 times a would give us 2. Then we get to plus or minus the square root of 12, all over 2. Then we get to plus or minus 2 square root of 3, all over 2. Then we're going to divide out a common factor from our triangle there. And there you go. So all of our solutions are at 4, and then 1 plus the square root of 3, and then 1 minus the square root of 3. So not nice, pretty whole number solutions, but solutions nonetheless. Those would give you decimals. And that, again, if you go back to the graphing calculator, you can kind of see that the other 2 places where the graph hits the x-axis are not on nice, pretty points, right? So that's why that happened. Okay? Sorry about that last example. Hopefully this helped, since you actually got to see the graphing calculator. All right? There is a couple more for us to do. Okay? So let's go through and type this into our graphing calculator. So we go to y equals, clear that out, and we need the function x to the 4th minus x to the 3rd plus 2x squared minus 4x. Uh-oh. Let me go back. These are all in exponents. I forgot to hit my arrow over. So anyway, I'll go back and retype. You probably didn't have this issue, so you should be in good shape. But I'll retype mine. Plus 2x squared minus 4x minus 8. Okay, now graph that guy. And it looks like this. Kind of looks like a parabola a little bit, doesn't it? So this seems to be hitting the x-axis in only a couple of spots, which means we may end up having a couple of imaginary solutions. So anyway, that doesn't matter a whole lot. We're only allowed to get one solution from the calculator anyway. So to get that solution, we can go second, and then table, and then we're looking down the y column to find zeros. There's one here. So you could use 2. If you arrow down, I wonder if we'll find another one. Well, it doesn't look like it. So I wonder if the other 0 is not a nice, pretty whole number, the one that we could see. That's okay. We'll just use 2 in our synthetic division. Okay? So let's do exactly that. 2 in our synthetic division, which means that one of the factors is x minus 2. Oh, by the way. And do our synthetic division. So 1, negative 1, 2, negative 4, negative 8. Then we're going to drop this one down, multiply up, multiply up, multiply up, and multiply up, and we get a remainder of 0, which is what we want. So we drop a degree, and these are all the coefficients of a new polynomial. And from here, we want to factor. Go back to our homework from last time and factor by grouping. So we group, factor out an x squared, factor out a positive 4. Wait, this was plus 4. So we get x plus 1. And our parentheses match, so our factors are whatever is on the outside of the parentheses and whatever is on the inside. We cannot factor anymore. We can't factor that guy anymore. So we're ready to set our factors equal to 0 and solve. So we get negative 1. So it turns out negative 1 was the solution also. And when we set x squared plus 4 equal to 0, we get x squared equals negative 4. We square root. And plus or minus, pull out an I, square root the 4, and we should get plus or minus 2i. So 2 of our solutions are real solutions. The other 2 are imaginary, which is why we only saw the graph hit the x-axis in 2 spots. Right? So all of our solutions, if we wanted to write those out, would be 2, negative 1, 2i, and negative 2i. Okay? And yes, that is a negative 1. Hopefully that made sense. There's one more in our notes. So I'm going to let you type that into your calculator, use the table to find a solution, then go do your synthetic division and factor from there and find the rest of your zeros. So go ahead and stop the video, give it a shot, and then you can start the video back up and watch me do it to make sure that you're doing everything correctly. Okay? Okay. So let's go type this into our calculator. So we've got x to the 4th, I better arrow over, then plus x to the 3rd, then arrow over, then minus 4x squared, plus 8x minus 96. Then we hit enter and graph, and your graph should look like, whoa. Okay, so we do see where it hits the x-axis in a couple of spots. Since we can't see the whole graph, maybe it will out here too, we just can't see it. But at least it gives us, and we're only allowed to get 1 0 out of here anyway, so we can go to our table and start arrowing up or down to find our zeros. And so you find one here, there's 3, and these are all the positive x values. If you arrow up, you get to the negative ones, and you'll find another 0 right here. So you can do -4 with your synthetic division, or you can do 3 with your synthetic division. It's up to you. It doesn't really matter. You're only allowed to grab 1 from your calculator, right? So let's do, since we've done a bunch of positives, I'm going to do -4, just to be a little bit different this time. So I'm going to put -4 in the tiny box, which means that, oh, by the way, a factor of this guy is x plus 4. Then we need our coefficients. Drop the 1 down, multiply up, add those, multiply up, add those, multiply up, and then add those and multiply up, and we get positive 96, which is a remainder of 0, which is exactly what we want. Now it means that we drop a degree from a 4th degree to a 3rd, and we use these guys as our coefficients. And now we're going to do some factoring. And since it's an x to the 3rd in 4 terms, we're going to factor by grouping. So factor out an x squared here, we get x minus 3. Factor out a positive 8 here, and we get x minus 3. Then your factors turn into x squared plus 8 and x minus 3. We cannot factor x squared plus 8 anymore, so now we're ready to take our factors over here and set them equal to 0, add the 3. Then x squared plus 8, subtract the 8, then square root, and we get plus or minus 2i square root of 2. So there are our 2 imaginary solutions. So this guy, although there are 4 solutions, will only hit the x-axis in 2 spots. To be nice and organized, we ought to write out the solutions, which are -4 and 3, which we actually saw from the calculator, which makes sense. And then we've got 2i square root of 2 and -2i square root of 2. And those are all our solutions. Okay? All right, hopefully that made enough sense. You can use your calculator now to find a 0, then do synthetic division, then factor, set your factors equal to 0, and find the rest of them. Okay, a little bit of work, but welcome to Algebra 2. Okay, your homework is out in Canvas. Make sure you get that done by next time.